Hey, everybody, thanks for joining us for our next TapRooT podcast. Alex, we're talking about innovative corrective actions today. Why are we talking about innovative corrective actions?
I mean, right out of the gate, it's because people need help.
I would think corrective actions are pretty straightforward. What do people need help with on that?
So, what I've seen, and I know you've seen it too, with a lot of different techniques, people end up doing the same thing again and again, and they expect different results. And I don't know about you, but that's the definition of insanity, and I don't want to go insane writing corrective actions.
So, like retraining.
Yeah, those corrective actions, retraining, rewriting a procedure, making it longer. There's a lot of things that we see people doing again and again. Now, we know with TapRooT, we're giving you those corrective actions to fix, but I think I want to kind of spread this out for a better philosophy and a better understanding of corrective actions, because there's a lot of different techniques out there across different disciplines that help people think about corrective actions, and I don't know anywhere that puts them all in one place.
So let me ask you something before you get too deep into it. So I went to this talk, and the guy's up there, the expert, if you will, and he's got all this data on corrective actions, and one of his points, he said, this particular study, they found like 30% of the corrective actions proposed didn't fix the problem. So for you, what's that indicating in regards to investigations and corrective actions?
So I think you have to start, before you're ever going to have a good corrective action, you have to have good root cause analysis. Now, the point of this podcast won't be to talk about root cause analysis, but I think I have to state that at the beginning, that if you don't understand the problem, it doesn't really matter what you do. You're not going to be fixing it. You might get lucky, but most of the time, if I see a lot that people will write bad corrective actions because they never took the time to understand what root causes they were trying to address. So for an example, there's some techniques out there where you get people in a room and they might brainstorm. What are our problems and what do we need to do to fix it? Well, a lot of times when you get people in a room to brainstorm corrective actions, there's somebody comes in, they've got their best practice, they've got their hammer,
Pre-notion.
their notion of what they want to do, and that's the goal of the meeting for them, is to get their hammer and find that nail that they could use it on. And so a lot of people will do bad corrective actions, or maybe they're good intentions, right? They're good corrective actions, but they're not going to fit the incident they're working on because they're coming in with bias of what they want to do. And we see this all the time with investigations, that somebody's got a corrective action and that's biasing their entire investigation. What are they learning? So I think at the front of this, we have to say that you need to do good root cause analysis to do good corrective actions. Now, that being said, you've got to do that. Once you actually have a list of root causes, how do you go about doing better corrective actions? That's kind of the next step. And I want to talk about maybe 3 or 4 different techniques that would help people.
Now, these techniques, are they to get the good corrective actions or the innovative, or a little bit of both?
A little bit of both, because anytime you're doing corrective actions, it's an exercise in creativity.
Okay.
So, I can't tell you that, you're always going to be able to do the best thing possible, right? We know there are hierarchies to this. Some safeguards are better than others. Some safeguards are worse. And so anything that we're doing to improve our system, they're going to be somewhere on that spectrum of spectacular to necessary. So there's some things that we have to do just because we can't do anything else. So part of these techniques will help us think about how do we figure out what's the best thing to do. And some of these techniques are more about helping people understand what they're trying to fix.
So give me some more detail. If we're going to do the brainstorm, we got our innovative people together. What's those, points that we need to make sure we cover or address? Summarize those.
So I'll give you the things that I want people to look at. We're going to talk about a topic called Poka Yoke, which is mistake proofing. That's Japanese for mistake proofing. We're going to talk about I've got the safeguard hierarchy, the hierarchy of controls. Sorry. So this hierarchy of controls, pretty standard technique people use out there. Those are kind of some standard ones. I also want to bring in some of the things that we talk about. So I've got a safeguard wheel that we can use to think about safeguards. And I want to just talk about the differences between corrective actions that focus on systems and corrective actions that focus on people. So
Okay.
I think if we have those topics, that should be a pretty good idea for how to be innovative and how to think about corrective actions.
So let's go right to Poka Yoke, mistake proofing. Is that where we start?
That's a good place to start. For those that don't know what this is, it's a Japanese term, stands for mistake proofing. It used to be called Poka Yoke, which is idiot proofing. And it came out of manufacturing. Toyota system is commonly credited, and looking at lean is commonly credited with spreading this idea. And the idea with idiot proofing, that's one of I prefer to say that one because I think it's a funnier one. The idea with it is, how do you make it where someone cannot make a mistake? If I put an idiot in the system, they couldn't screw it up. All right. So they have a couple different, if you want to think of processes, they say start with elimination. Can you get rid of the process altogether? So if you were thinking of automotive, I think there's a story from Elon Musk at Tesla, and they had this, it was a mat that would go on over the battery. And they were spending time trying to optimize this step in the manufacturing process of a Tesla. I think it was when they were doing the Model 3, if I recall the story. And they're wasting all this time. They were dealing with problems with it. It was slowing down the process, and they're trying to optimize this. And they took a step back and said, hey, do we need this mat? What do we need it for? And engineering said it was for this reason because safety said we needed it. And safety was like, we never said that. Engineering's the one who needs this. And what they both found out is each group thought the other had a purpose for this mat, and they didn't need it at all. And instead of figuring out a way to optimize it and make it where people won't have a problem installing it, they got rid of it. And that's elimination at its point there, is the idea that, do I even need to have this step at all? Because they can't make a mistake doing it if it doesn't exist. So that's the idea of elimination in mistake proofing. Now, I tie this in when we think about these different techniques. There's two other ones. There is the hierarchy of controls, and then there is the thing that we teach, which is the safeguard hierarchy.
Okay.
And the first step in all three of these looks the same. So they do both Poka Yoke and hierarchy of controls say elimination. We call it removing or reducing the hazard.
Mm-hmm.
So that's kind of our concept there. So in the hierarchy of controls, we're not talking about mistakes. We're talking about control of energy. And so again, their first step is elimination. Can you eliminate the energy source? That ties with the same thing with safeguards from us. Can you get rid of or remove that source of energy? Get rid of it. This way people can't make the mistake. They can't get hurt by that energy if it doesn't exist. So I think the first thing you should be doing when you're being innovative with your corrective actions is take a step back and say, can we change this process? Can we get rid of that hazard? Do I have to have that energy present? And so that's a good starting point for most people, because I think a lot of people, they spend all their time going, how do I make it where they're more likely to do the thing I told them? Right? That's where everybody starts in corrective actions, discipline and training, right? Telling them to do it. We need to go to the other side of that and say, hold on, can I get rid of this energy source? Can I get rid of this hazard? Can I get rid of this process step so that no one is going to make that mistake?
So, what if we can't get rid of that process step? Let's, for example, go back to your story about the mat. The mat has to be there, but we're still making mistakes. So, like the safeguard hierarchy and this Poka Yoke mistake proof and stuff you're talking about, is there a next level?
Yeah, so when you can't eliminate, this is now where a lot of the techniques are looking at how do we make small changes. So from the idiot proofing, on the idiot proofing side, they look at, instead of elimination, they say prevention. So how can you prevent somebody from making that mistake? I think the most common example that is used for this is a simple plug. So when we think about, I think my favorite one, and there's a picture we use in our human error course for this, it is from a hospital. And they've got different airlines. You've got oxygen, you've got pressurized air for things. There's a lot of different airlines that you might have for hoses that would be plugged in.
Mm-hmm.
Maybe it's gases that need to come in. Maybe there's other stuff that needs to be piped into areas. Well, I don't want to be using an oxygen. I have an oxygen line that's going to go into something that is going to explode if it has oxygen, goes through pure oxygen to it. So I don't want people making a mistake plugging in the wrong hose into the wrong slot. So instead of having it where this hose can plug into any of those airlines, you can have that hose plug only fits the oxygen line. So the oxygen hose only plugs into that oxygen line. It's a preventative measure that's built into the actual device. So another common one that people think of is they think of like phone chargers. So you ever had a USB,
Yeah, they've changed them all now. Used to everything fit everything. Now you got different stuff.
Well, so the old USB device, you never could plug it in the right way the first time, right?
Oh, no.
'cause
Actually, it took 3 times. The first way you tried it, turned it around, still didn't work. Turned it back the way you had it, and then it worked.
Exactly. So having a unique side, well, things that you can do, and they did this with the USB 3 update and so forth, which is make it where any direction you put it in, it works.
Nice.
Right? So that would be one solution you could do. Another way that people have solved this is by doing things like, if I've got to plug it in a specific direction, you change the shape of one side so that you always know, I'm looking at like 2 holes.
Mm-hmm.
I've got a third hole on the top, and I know that it's always going to have that third hole on the top. It's got to be that direction. So those like directionality things, you can change something in the design and in the shape of it to make it where people can't make that mistake.
Okay.
So that would be, again, prevention.
All right.
Taking this to some other types of techniques, and maybe we don't want to jump around so much, but when we think about this from a human error and a mistake point, how do we be innovative? How do we change that? We call it human-machine interface or human factors. How do we make it where it's easy to do right, hard to do wrong? That's prevention in my mind, is how do you make it where it's easy to do right, hard to do wrong? Thinking again back to Poka Yoke, Poka Yoke, you've got elimination, you've got prevention. The next is replacement. And this is similar to, for those familiar with the hierarchy of controls, next on the line for them is substitution. So in replacement under mistake proofing, it's about making the process more reliable to lessen the chances of error. You're replacing complexity with simplicity. So how do you make it where what we're doing is a easier task to be completed? And how do you go replace steps? So instead of like, if I'm assembling something, instead of me having to take all of these unique parts and put them together, maybe I have a pre-built box that I'm now using. So I'm replacing this operation where it used to have all these additional steps. Now it's a simplified process where I get this pre-made box and I just put it in there instead of having to build a box around something. That would be an example of you're replacing a step to make it simpler and harder to make that mistake. So when we think about these things, as we've got stuff coming in, we're replacing it to make the process simpler. In the more typical safety type, we would call this substitution. So in substitution, you have, let's say we have a dangerous chemical. We've got a glue, a solvent-based glue. Well, instead of using this solvent-based glue that now has all these requirements to it, we use a water-based glue. Now, as long as those two equivalents produce the same result from a process standpoint, you've made your system better because you have something that's less dangerous or less caustic or less hazardous, and you've reduced it by substituting in something that is simpler. So again, when we take this and we think about our processes, where can we substitute out, where can we swap out things to make that safer, less energy, less opportunities for mistakes?
So this is more, you're not having to totally re-engineer the entire process, just change some aspects of it.
Yep.
Which sounds a lot more cost effective maybe sometimes than and stuff.
So I tend to think of this, and again, sometimes, and people, this ties in too with kind of the next one, because when people are thinking about how do we modify the process, replacement is more about how do we actually change the process steps, how we do it. But there's also another level, which is kind of the next one in there, which is facilitation, which is can we add a tool that facilitates that and makes it easier to do right. So again, tying this into something, a torque wrench. So let's say you've got a process that requires you to torque something to a specific, torque. Now, maybe it's just something that has to be so tight, right? Your current standard is it's got to be tight.
Okay.
Well, how do I know how tight it has to be?
Yeah, what's tight?
It's my cheater bar, and I crank it till it doesn't move anymore, right? That's the current process. Well, the better process would be we give them a torque wrench and we tell them exactly how much to torque it to. And that way you can set it, and once it clicks, you know you've got it tight enough. So that's, again, the idea of facilitation. Can we give them a tool? So you could change the process, replace one step with an easier step, or you could give them something to facilitate that process and make it easier for them to do it the right way. So again, when we think about these things, different techniques would call it something different. So again, and I'll cover these as we go and talk in depth on them, but and I'm sure they'll throw some graphics up just as we move through these to keep people in there.
Well, you're talking in pretty good detail right now, in my opinion.
Yeah, help them out with those. Visualize.
Okay.
So again, we think of these different areas. Now, in TapRooT, the way we refer to this, there's kind of ours is a little bit more human performance based. So instead of saying substitute, we don't really have a substitute spot. We have reduce hazard. So remove or reduce. So if you reduce the hazard, you might be substituting it. We talk about remove or relocating the target. So in TapRooT, target is the person you're trying to protect. So maybe from a safety standpoint, you might move that person to a location where they're safe, or a location where they're further away from the hazard. Or you're relocating those controls so that that person is not near the line of fire, right? So again, a lot of these concepts can kind of come, we're trying to think about how do we change the process. And that's what makes things innovative or not, is it's not how do we fix people, but it's how do we set our processes up for success. So again, going through the mistake proof, and we'll move to the other ones, they have replacement and facilitation. That's how can I replace something in the process to make it easier? How can I give them a tool that facilitates the process and make it easier? Well, if you can't do those things, then they want detection.
Okay.
Now, that detection is detecting that a mistake has been made. So from a process standpoint, I always think about, there's another, again, famous kind of lean example. You've got a conveyor, and on that conveyor, it's looking at boxes. And the only job of this camera is to make sure that only blue boxes pass through. So you got blue box, blue box, blue box, red box. Well, it sees a red box. What does it do? Kicks it off.
Okay.
Kicks it off the conveyor, right?
Yep.
That would be detection.
Okay.
It's looking. When you think about these things, you've got to come up with a method for detection and mitigation. So those are kind of two things that come together in my mind. They're separate steps, detection and mitigation. Detection would say you've got a blue box on the conveyor.
Okay.
Mitigation is knocks it off the conveyor, right? Separates it.
Okay.
Another way to think about it is fire alarm and fire suppression, right? My smoke alarm is going to detect that we have a fire, but that doesn't stop a fire, does it?
No.
So mitigation would be like your sprinkler system. Again, you've got something that heats up. Once it gets over a certain temperature, which would be caused by a fire, it sets off. And then your water comes out. That's mitigation. So when you tie those two things together, you get a good process for reacting without involving a person. Now, a lot of processes, they have detection, but they rely on maybe a human input to activate mitigation strategies. So I think of it like a lot of alarms are saying, hey, there's a problem, there's a problem, there's a problem. Well, it takes a human then to go, one, shut off that alarm, and then two, take action. And so anything you can do in your process that makes it easier to take action and easier to mitigate it and more automates that mitigation is going to improve your system.
So even trying to influence what humans are doing or not doing.
Exactly. So, and again, think of, we use the example of the airline that crashed. We won't talk in too much detail, but there was an alarm that wasn't heard in that scenario that we talked through with our students in the 5-day.
Mm-hmm.
And it's supposed to warn them, pull up, right? That's supposed to alarm with a certain amount of time for them to take action. Well, if that detection mechanism is set too low, there's no time to correct. They don't have time to pull up. They've already entered into that state. So you have to look at, we call it fault tolerance. That's what TapRooT term is for it. The idea is that if somebody makes a mistake, can you detect that mistake, and do you have time to respond to it? So that's the idea, is from a mistake proofing standpoint, can you eliminate the step, make it where it doesn't exist? Can you prevent them from being able to make that mistake? Can you replace that step so that they're less likely to make a mistake, make it easier, simpler to do? Can you facilitate the process, give them a tool, give them something that's going to make it easier for them to do and be less likely to make the mistake? Can you add a detection mechanism to detect if a mistake has been made and alert? And can you add a mitigation device that's going to mitigate that step and or mitigate that failure and recover and prevent it from being something worse? So that's kind of how to be innovative. And that technique comes out of Lean and out of kind of the Japanese philosophy of Poka Yoke, of mistake proofing.
Okay.
So that's one method, one philosophy.
So I got to get your opinion before we keep going. I've got this, when I saw we're going to be talking about innovative corrective actions, I was thinking about it, and one that I thought was a really good idea. And I'm sure toilet stories wasn't on the podcast viewers bingo card today for joining the TapRooT podcast, but I'm going to tell it anyway. So it was a school, and the problem at the school, and I can't believe this would ever happen, but the kids were knocking off the porcelain sinks or damaging them and all of this, and they were going through all of these things of like trying to, have the hall pass, figure out who was the last one in the bathroom. Teachers are having to take time to track who's going when and where and what, and dedicating resources when they should be teaching the class to try and figure out who's tearing up the toilets. And I guess you would call it re-engineering based on what you said, but eventually they just moved to stainless steel sinks. So, you can't break. So you can dent it, but you can't break it. And I kind of always thought, that's a little bit of a pretty innovative corrective action, in my opinion, because they can't go break the sinks anymore, don't have to worry about people with these undesired behaviors and things. So, in your opinion, based on what you said, I feel like it's a little bit of a combination of a couple of the points there. So, your comments on that?
You can't get rid of the toilets. It's not elimination. You can't get rid of the bathroom. You got to have a bathroom, but we want to make something that's harder to dent. So it's a good example of kind of trying to do some prevention and a little replacement, right?
But it did eliminate that negative behavior they had of people going and doing things they shouldn't do.
Plus, you'll hear that loud bang.
Well, sure, but when you're talking about elimination, is that step just the focus on what we call the hazard, or is it also, can you be eliminating an undesired action or behavior. How's that fit?
Yeah, so this is a good difference between the concept of mistake proofing and really what's more like the hierarchy of control.
Okay.
So from a mistake proofing standpoint, that's not an elimination. They could still break it, right? You've got to have a bathroom. You can't eliminate that step. You can't eliminate that process. You got to have a bathroom. You don't have to have a toilet that you can break. So you can do some prevention. You can make it a hard to break toilet or a hard to break sink.
Okay.
Right. So in that standpoint, it's what's the mistake? The mistake is breaking the toilet. Or what's the problem you're trying to solve? You're trying to stop people from breaking it. Can't eliminate them, but I can prevent it. I can replace with something that is going to be stronger.
Okay.
So that's over there. If you think of the hierarchy of controls, and again, maybe we'll put this one up here for people to see what's that hierarchy of control look like. From that, it's about control of energy. So then we're thinking, what's the energy involved in this, or what's the process involved? So how do I control this? Well, again, I can't eliminate toilets, got to have them, but I can substitute something that's easily breakable for something that is less breakable. So I again say that's pretty strong. It's a good corrective action. It's focusing on the strength of things. When you're doing corrective action, when you're thinking about it, it's the right philosophy. Can I get rid of it? No, got to have toilets. You could have also tried to do, you say weaker things, right? The weaker things would have been like, oh, you've got a key. Now we're putting people to watch the bathrooms. Now we're taking all these resources to let people in and out and police who's going in and out. Well, those are a lot weaker than actually just putting in something that is stronger, to less hard to hurt or less easy to damage. So those are the kind of things, again, I think it's a pretty high on corrective action lists.
So staying with that, the weaker stuff, that was actually that organization, that was the first thing they tried, was putting the teachers, the faculty, the staff in charge of monitoring this, handing out the key to the toilets, things like that, and they were still having the problems. And so had they maybe went and did this process first and not wasted the resources and time beforehand of the weaker corrective actions, they would have saved themselves some more heartache. With that, like obviously you have a history, you have studied Poka Yoke, you know those principles, and of course TapRooT, you're an instructor. But are there things out there for people maybe who are visual learners that serves as a cue? Here's what you need to do, here's how you can implement these, or get them a cue of thinking about these things.
Yeah, so it's a good tie-in to when we talk about kind of my work on this, which is the safeguard wheel or energy wheel. Before I pull up the graphic for that,
okay,
what I want to state is also a good concept of why. Why do people start at that bottom? What do you think drives the psychology? Why did the school start with these things that we know didn't work, and we know from experience don't work very well? What would make the school start with things like sticking the teacher out there, catching those kind of things? Why would they start with that, you think?
Well, I know from class what people say and different things. I know in that situation, it was cheap, easy. They already had, people there, and they thought, this will be an easy, quick solution, and just stick the person out there and we ain't got to worry about it anymore.
Yeah, so a lot of times companies are trying to solve this problem quickly and easily. And I think it comes from a philosophy of there's a person to blame and I can fix them. Now, in this case with the toilet, if it was just one person breaking the toilet, if we found that one student, disciplined or kicked them out of school, nobody's going to be breaking our toilets again. Those toilets sat there for who knows how long without ever being broken. Yeah. So in that defense of the school's at least original thinking, right, they were just trying to catch who's involved and fix that person. And if they could have done that, they wouldn't have had to replace anything because their current toilets would have been fine.
But now that you say that blame, I mean, even staying on that same topic of public entities and things, that's always like on the forefront. I mean, people instantly want to know who's at fault for this. In our media things, you see an accident and they want to know,
if we could just blame that one person.
Yeah.
So I think in some cases, and again, when it comes to sabotage, That's what we're really talking about with this case. This is an example of sabotage. Somebody's willfully going out. There is an element of you do want to catch and prevent, and detect those opportunities. So in those kind of situations, if you could catch, that would at least make it where this problem ends today. But when you think about, well, how do I mistake proof? How do I sabotage proof? Because a lot of people are trying to sabotage proof their systems as well. They don't want somebody to come in, a disgruntled employee, to destroy something that's worth millions of dollars or damage it. And so when you think about how do you sabotage proof stuff, one, it might be a futile exercise because we're really creative as people. We can break just about any system. We're very creative at doing that. But you start off with safeguards. Again, this philosophy of how do I make it difficult to, in this case, sabotage? Can I eliminate this process so they can't sabotage it? Can I prevent sabotage by engineering it so that it's very difficult to do it wrong? It would be very difficult to sabotage. So those are still the kind of thinking that you would do, is say, hey, we want to prevent this from being a problem in the future. Maybe we can catch this one person that broke it this time, or maybe we caught the person that sabotaged it this time. But how do I prevent it from being, how do I eliminate that weakness we've now found in the future? So again, maybe the toilet's not the best example of that, because if again, cost-wise, it would have been a lot cheaper to just kick the student out and put in the cheap toilets.
Well, it was multiple students.
And that's the key. It's not one person sabotaging. Now it's a trend of how funny it is that we're breaking every sink in the school.
Yeah.
Right. And so, it's hard to fight a cultural trend with discipline, right? We know that. The more they crack down, the more the students are going to rebel. That's a cliche, but it's probably true, right? Mm-hmm. So I think there's a cultural element that you have to think with these when it comes into intentional mistakes versus, we'll say, the unintentional, right? The intentional error, the sabotage versus the unintentional mistake. So I think the majority of times we're going to be talking about unintentional, because at least in safety and quality, people don't want to produce bad quality. They don't want to get injured on the job. So just tie that little part about culture in there.
Yeah.
So let's go look at mine. We'll pull up the
hazard wheel. You mentioned that, or not the hazard. I apologize. Safeguard wheel.
It's got a lot of names. It's got a lot of names with corrective action wheel, safeguard wheel, but it follows a similar philosophy to Poka Yoke, but there's some subtle differences, and they tie into energy. So again, what we teach in our courses is looking at the hierarchy of safeguards. What safeguards are most effective? What safeguards are least effective? And for us, we know the most effective thing is remove or reduce the hazard, remove or relocate the target, guard the target or hazard, improve human performance with good human factor design. Those are the strongest things that we can do. So this wheel is about how do we do the top side of the hierarchy? How do we guard, remove, replace those philosophies? And so it starts with the same concept of elimination, remove. If I can get rid of a hazard, if I can get rid of a process step, that's the strongest thing I can do. Can't make a mistake if we get rid of it. Similar to hierarchy of controls and similar to Poka Yoke, the idea is replace. Reduce and replace. Can I sub out that process? Can I reduce how much I need? Can I get that energy less? And if I can't do that, can I relocate? Can I move things away? So what I kind of think of this first little quadrant of it is about reduction. Can I reduce the process? Can I reduce the energy? Can I reduce the chemical? Can I reduce the potential for harm? And if you can take away things that are dangerous, it's less likely that people are going to make a mistake. So those kind of quadrants mirror up really closely with those other two philosophies.
Okay.
Where we get to be a little different is starting at that relocate idea.
Okay.
Relocation of targets and hazards is not exactly well brought out in, let's say, the term substitute. It falls in there, but people don't really think about it well. So I always like the example of pinched finger. If you've got a big metal press that's stamping, let's say, steel plates, making a little mold, stamps them into a shape, what's the thing you're worried about?
Me sticking my hand in there,
and getting it flattened like a pancake. So what do people do? You ever seen somebody put a little double trigger?
Yeah, the two-hand operation, things like that, lockouts,
Yeah,
that sort of thing.
So,
Sure.
So the idea with that would be we want to move those hands and put them in a place where they have to be engaged in a safe location. That's relocation of a target. We need to think about this from a control standpoint. How do we put this person in a position where we are going to know that they're safe? And a lot of people don't take that approach. They just think, well, we're out of control, or we can do all these other things, or we can't remove the hazard. Well, you can put that person in a safe place. You can put them in a state you know will be safe to do the action. And if you think about it that way of how do I relocate the person, I think that really helps make it clearer what you're trying to do. Whereas things like the word engineering controls or substitution doesn't really tell you that. It's an engineering control, putting those hand controls out of the way, but it's really what your philosophy is where do you move the person to put them in a safe position. Something else that we do that's next in the wheel is kind of about adding. So the first part of the wheel is about reducing. How do you reduce harm, reduce injury, reduce energy potential? The rest of the wheel is focused on how do you add defense in depth? How do you add strength? And the first way to do that is by adding preventative measures. Again, tying back to that thinking from Poka Yoke, how do you prevent that mistake from occurring? Change the tool, change the shape, change the form. Something that people don't think about. You've been out in oil fields and stuff, and you've seen that flare going off.
Mm-hmm.
You know, you ask somebody what's that flare. Now, if they're not in the industry, they have no idea. It's burning off something. Who knows what? If they're in the industry, what they'll tell you is they're burning off methane or some other excess natural gas or whatever. They're burning off something that's coming out of the product, out of the ground, that's not the product they're there for. A lot of green energy right now is doing stuff to capture those extra gases. Maybe you can sell them. Maybe you can use them for things. I know some facilities that are catching that gas, burning it off for power.
That's a cool idea.
Yeah, lots of cool things.
That sounds like a fairly innovative. I don't know if you class it as a corrective action.
Well,
but
it's always about finding unique uses for things, right?
yeah.
But one of the things that fire, that flame, that flare has a value is it creates a pressure. So you don't want a backflow of pressure to go into the system. And by having this flare, you're actually creating a pulling force that prevents that air, that gas from going back into the system and causing bubbles, causing problems that could explode, things like that. So actually by having a flare, you're actually preventing a different problem. So not only is it, potentially providing some other benefit or having a purpose for burning off, excess methane or something, but it also has this benefit of a preventative measure to it. And so when we think about processes, how can we add in those preventative measures is a way of strengthening your system.
Would that fall into protection a little bit too? Are you getting into that protect phase with this type of area of your safeguard wheel?
Yeah. So this is, like I said, it's in adding, and this is putting in place a system preventative measure.
Okay.
Now you've got different types of things, and if you go around this wheel, now we're in the adding side. You've got prevent, you've got stop, detect, contain, guard, and protect. Now, when I say protect in this measure, protect is protecting an individual. That's the target, that's the person. It's protect of an individual. Guard is guarding the hazard. Contain is containment of the hazard if it becomes uncontrolled. Stop and detect are tied into that, very similar again to that lean philosophy of detect and mitigation. So methods of detection are needed and methods of stopping that once it's been detected. Contain is about limiting the exposure. Guard is about physically putting physical barriers between people and those hazards. And protection is about putting physical barriers to people. I think of it typically as PPE, physical barriers to people and energy. So again, I subdivide out, when I was doing these, I subdivide out some of this stuff because I want people to think about it in different ways. So again, we got that first one we just talked about, which is the prevent. That's very different from stop, because prevent is, I want to prevent it from being possible to make this mistake. Stop is, how do I stop the process once a mistake has been made? So
to recover.
Exactly. It's about recovery. My favorite example of detect and stop, and it's so simple. We don't even think about it, but all of us, and I'm glad you mentioned toilets, because we're bringing up toilets again.
Hey man, tune in to TapRooT for that toilet humor, you know?
But in your toilet, there is a valve in the back of your toilet. There's a stop, and when you flush it, you got that process that sucks all the water out, and then that back of that toilet starts filling back up.
Unless the flappers wore out.
Unless the flappers wore out. So what happens? It gets to a certain point, and what happens? You've got a little...
The bladder goes up, it cuts off.
You've got a floating bladder, and it goes up, and it basically shuts off the valve.
Oh, I know toilets. I'm the feared toilet fighter, buddy, I tell you.
So that floating valve is a easy mechanism for stopping it. It doesn't require some advanced AI system. It doesn't require some alarm to tell a person to run over and twist the water thing. It's built in, and it's low skill, low complexity. It's a very simple mechanism relative to a lot of things that people have as safeguards. And I just think those are the kind of things that we should be thinking about. How do we make a low-skilled stopping mechanism?
So sometimes people get themselves in trouble with, like, their concept may be great, but overcomplicate the fix. Is that what you're kind of saying?
Yeah, over-engineer it. Right?
Over-engineer.
They want to over-engineer the fix. And I wish I could remember. There's a full story with the over-engineering fixes kind of thing. But again, the idea is, why do something really complex to fix the problem if you could have something so simple as a floating valve that just stops it off? Like, I wouldn't need to have, imagine in your toilet if you had a level sensor. You had a redundant, because you have to have redundancy. You had a second level sensor. You had a level alarm in case it went over that level sensor. You had a control flow valve that would tell you how much flow is going through so that you could adjust it. And if it got too close to that level alarm, you were supposed to, manage it. Imagine how complicated that's. I mean, there's a lot
Plus, you're dependent on me to go react to it.
Yeah. And there's a lot of, and I'll just talk storage, water tanks, storage tanks, oil tanks. There's a lot of tank systems that have 70 different systems looking at flow. And they all rely on, at the end, they've got a floater valve that's the very final safeguard, just because it's low tech, but it works. And so those are kind of things that, I think we should look in our system of how do we put in place these detection mechanisms and ability to stop. And the same is true when we think of, again, a fire suppression system. I think it's really cool. I don't know if you've ever seen it, but they've got these, they're like fire turrets. And you've got this like turret thing. It's got an AI camera that's looking at heat things. It sees a fire, it turns, and it shoots it. That thing is super cool. And it's got a practical use, because instead of setting off an entire sprinkler system that destroys everything in the facility, you've got this targeted way of putting out a fire. I think I saw one that was in use at a recycling or garbage facility, because they get fires all the time because people throw out their batteries. Anyway, so they were like testing one out that was like, it detected a fire, shot it, boom, put it out. It was cool. But those are the kind of things that's really complicated, and it could fail a lot. Maybe there's a motor that failed, and so it can't turn all the way. Maybe there's something in the detection software that doesn't respond properly. It's got a lot of modes of failure. Whereas a simpler sprinkler system that once it gets hot enough, it melts this thing that sprays out the water. I mean, it does fail, but it's hard to make it fail. Once the fire gets hot enough, it's going to happen. So those are the kind of things. It's like, how can I make a simplified, lower tech solution that works effectively? Oftentimes people they think innovative is the fancy cool turret. I think innovative, honestly, is the low tech solution that works really well. I think there's a time and place for both, and there's a need for both. But man, I do love simple solutions.
Let me try to trip you up and throw a curveball. So you're talking about, you were mentioning the safeguards and the targets and the things like that. When you're looking at corrective actions, you're thinking about those things. Correlate that to like a quality type situation. You know, safeguards, you said you're preventing that hazard from coming in contact with that target, things like that. What about in a quality type space? I mean, these same hazard wheel type stuff apply there?
Yeah, so there's a little bit of a tweak for quality, because when we say hazard and quality, it doesn't quite land well with them.
Okay.
Because it's energy. And when you're thinking quality, you need to think about defect. So what is the process defect, the quality defect you're dealing with? Well, that defect is actually caused by energy, right? It might be misapplied energy. It might be something, tied to it, but there's a defect. So if you're dealing with something like maybe we put a nick in a part, or maybe there was something, bad in that process. If I can remove that process, remove the ability to make that defect, that mistake, I'm going to be in a better situation. So instead of saying hazard in these situations, you'd say defect. Again, quality, they're looking at prevention of the consequence of a defect, whether it's sending it out to a customer or scrapping it or it causing some bad thing to happen in their process. That's the defect they're trying to prevent. So again, you might sub out the word hazard with defect and then think about, how do I remove the process? How do I make it where you can't make that defect? How can I make it where if I make this mistake, the defect will be less than what I'm expecting? So I'll give an example from my time. We had these coated rollers that we had to install into a bearing, and they had this special coating on them. Well, if I used the process for installation on bearings is sometimes a horrifying one. If I used a hammer, now we wouldn't have used a hammer, but if I had used a hammer on there and I was hitting it with a hammer, I'd be nicking up this coating on there, special coating, taking it off. We didn't do that, but if somebody was, they would have.
I've done it on my trailer.
Yeah.
Yeah.
Hammering in a bearing. You could be nicking off a special coating. Well, for these, you had to insert them in there, and you had to shim them to protect them, because there's an edge on that bearing, and you didn't want that edge to scrape along those rollers. There was all these things that we had to do. Well, we had to have a special brass tool that had a lower scratch rating than the surface of the coating. So the tool would scratch, but not the roller. There's things like that we use. So you've got this tool that you're using. So again, you're trying to eliminate the ability to create that defect. And so by using a different tool, substituting out a tool, now we have less likely that we're going to have that defect. Now then you increase the chances of that tool disappearing or getting damaged or something happens to it. So, all these corrective actions do come with some elements of effectiveness. Finishing up the little wheel, kind of finish up this discussion on there. When we think about protecting, that kind of the last quadrant is a little bit about adding layers of protection to our system. So those bottom three, which is prevent, detect, and stop, that's about adding layers of protection to the process to prevent it from being bad. But what happens when it becomes uncontrolled? This is where you need something to mitigate. This is where you need things to help with containment. This is where you need guards and protective layers. So I kind of think of it in three different ways. Containment is containment of the hazard. So easiest thing, we're talking about filling up, overflowing toilet, right? The overflowing giant thing. If you want something to overflow, what do you want?
Something to catch it.
Something to catch it. You've got your containment walls, you've got your drip pans, you've got whatever it is. Something to contain it in that zone, contain that energy, keep it from escaping. So you want to have something in your process that looks for containment. How do I improve that? You want guards. The easiest thing, electrical. We've got electrical. We want insulation, right? How do you insulate that? Insulate the person from that electrical. How do you insulate the conductors from the neutral so they don't cause arcs? In any way that we can insulate the process, we can add those physical barriers. I think the most obvious one that everybody thinks of with guards is, and I'll state this, it's guardrails. Now, NASCAR, Formula One, big things around the world. What do they have on every track where there's people?
The fences, keep
Fences
the
and
cars
nets.
inside the.
And they're there to protect people from the cars flying at incredible speeds. You've got those guardrails, you've got those fences, you've got those barricades. I think, generally speaking, most industries are pretty decent at identifying some of those kind of motion hazards. We've got a rotating gear, we've got this spinning piece of equipment, let's put a guard on it. That's the simplest guard that you can think of. There's a lot more complex guards that exist for blocking off things. I think about light curtains. Those are really cool. We used to have, it was a process. It had there was a stand that would go up. It would heat up a metal ring that was used for assembly, and it would pop back down. Well, there's a light curtain on that because you wouldn't want to get your hand in there and that thing come down and take your fingers off. So, simple up and down mechanism for loading something up to that zone. But we've got this nice process to prevent people from having their hands in that system, a nice light curtain. There's lots of different things that you can have that kind of fall into this guarding, detecting, and stopping. And you don't have to be too perfect on which category it falls in. Just let the categories inspire you to come up with new ways of doing things. And I think the last one on here is PPE, protective equipment. When you compare where I think PPE falls in effectiveness to, let's say, the hierarchy of controls, and again, we'll put the hierarchy of controls up there, what they are. It's elimination. What the hierarchy of controls are. It's elimination, substitution, engineering controls, administrative controls, and PPE. Now,
PPE's on the bottom.
PPE's on the bottom. Why is PPE on the bottom of the hierarchy of controls?
Well, why don't you tell us? I know what I'm thinking. I'm thinking it's on the low end because you got to depend on a human being a lot of times to put it on.
So that's a common misconception, one that people say is, it's on the bottom because it relies on people.
Okay.
All safeguards rely on people. If you think about it, people remove guards, physical barriers. People remove sensors. They let things fail.
Like bypass the lockout, something?
Bypass lockouts. People bypass safeguards all the time. All safeguards rely on people to keep them in place.
Okay.
Now, how much it relies on them might vary, but PPE is at the bottom not because it relies on people, but because if you're relying on PPE to protect you, the hazard is in an uncontrolled state. So the hierarchy of controls is all about the control of energy, and everything in there is about what's the most effective at controlling energy. Eliminating it, I have complete control of it because it's gone. Substituting, I have control of it because I've reduced it. Engineering controls, I have control of it because it's being controlled by my system. Administrative controls, my processes and my system design, my people side of the system design, controls that energy. PPE protects the person from energy.
Last line of defense.
It's a last line of defense. But if we think about the difference between administrative controls and PPE from an effectiveness standpoint, what's more effective, PPE or administrative controls? What do you think?
What's more effective from a control of energy?
Not from a control of energy, from effectiveness at protecting someone.
Oh, well, I'm going to go PPE.
Yeah. So I always like to say this in class, what would you rather have? Would you rather have a fall protection harness or 3 points of contact training? Which one's going to be more effective?
Fall protection harness.
I'd rather have a fall protection harness on because despite how well I know that I need to be using 3 points of contact, that doesn't mean there's not going to be some situation that occurs that I lose 3 points of contact. So again, when we think about these things, PPE is effective, and we need to think of innovative ways to utilize protective equipment to keep people safe, because we know we're not always going to be in control of a hazard. As much as we expect to be, as much as we design our system to be, we want to have that safeguard in place in the event of some chain of events of failure that allows that hazard to become uncontrolled. So likewise, the way this wheel is, it's all about safeguards in your system. It's got nothing to do with administrative side. So I keep all of that out in this wheel. It's about how do we reduce energy, reduce mistakes, reduce error, and how do we add defense in depth that does not rely on policies, procedures, training. It relies on us to be creative and innovative in our thinking, and innovative in the way we roll out and change our systems.
How can I learn more about getting my hands on being innovative and changing my system?
I'll tell you the 3 best places to come for this. The easiest one to find at a location near you is the 5-day class. We talk about this topic in our 5-day training. Not all of these elements, but we talk about pretty much everything in here in our 5-day class. Beyond that, if you really want to go in depth on things like corrective action wheel, mistake proofing, this concept of human performance, the Stopping Human Error course that we put on, that Mark and I teach, it's a fantastic discussion of how do we think about our process and systems and make them stronger. Lastly, this, the corrective action wheel, the safeguard wheel, this came out of work I did for the TapRooT Summit. So the best thing you can do is come to the TapRooT Summit, find out about new best practices that are being shared by people in industry, users, and learn best practices there. So TapRooT Summit's always a great opportunity to learn more.
Awesome. Well, thanks for talking to us today about innovative corrective actions, and I'm anxious to get my hands on the corrective action wheel, and appreciate it.
All right.
Look forward to seeing you guys next time. That's it for today's TapRooT podcast.
They've got to make sure that they subscribe, comment down below, and we'll see them soon. Links are for everything I talked about are down below.
Oh, I forgot about that. Yeah, because we had some visuals and the links. Yeah, so I can get my hand on the visuals there at the links.
Yep, you can get all this information down below.
Awesome. All right, thank you guys. Enjoyed it. Have a great rest of your day. We'll see you next time.